All welcome back to my channel Hayadari. In today's video, we are going to see what exactly is multiple linear regression, and we are going to clearly understand the exact differences between linear regression and multiple linear regression. And also, we are going to see the important steps that you need to use for building complete multiple linear regression based. Without any delay, let's get started. We have already seen what is regression. What is linear regression? We have already seen the real world applications of linear regression and also hands-on coding when it comes to linear regression. So in this video, we are going to see these three topics. What exactly is multiple linear regression? Exact differences between linear and multiple linear regression. And finally, we are going to see important steps involved in building a multiple linear regression based model. First, what exactly is multiple linear regression? In linear regression, if my goal is to predict a particular column using another column, the column that I'm going to predict is called as dependent variable because I'm going to predict using another variable. The column that I use for predicting my dependent variable is called as independent variable. So that independent variable is also called as a feature and dependent variable is also called as a target variable. Now come to multiple linear regression. Here we'll be having so many features, not just one feature. So we'll be having so many independent variables, but one target variable and one dependent variable. So the major difference is in linear regression, one independent variable. In multiple linear regression, two or more independent variables. This is the formula that we are going to use in multiple linear regression. We are not going to use this formula, but inside an ML model, whenever I call my ML model multiple linear regression, inside the brain of this algorithm, it will be applying this formula. Y is equal to B naught plus B1 x1 beta naught plus beta 1 x1 beta 2 x2 beta 3 x3 until the number of values are there in a particular column. Here y is a dependent variable or my target variable. Beta naught is my intercept value. Beta 1, beta 2, beta 3 until beta n, these are all the coefficients. x1, x2, x3 until xn, it is independent variables. Let's try to understand multiple linear regression just by looking into one example. If I am trying to predict the price of a house based on area of the house, column number 1, number of bedrooms, column number 2, location score, column number 3, age of the building, column number 4. If I am using 4 different columns just to predict the price of the house, this is called as multiple linear regression. In case if I am using linear regression, I could just use area of house for predicting the price of the house, or I could just use the number of bedrooms for predicting the price of the house. This is the major difference between linear regression and multiple linear regression. Now let's try to understand the differences clearly by just looking into the table. The major difference is in linear regression we have one independent variable. In multiple linear regression we have two or more independent variables. The formula that we use for linear regression is y is equal to beta naught plus beta 1 x. In multiple linear regression, the formula that we are going to use is y is equal to beta naught plus beta 1 x1 plus beta 2 x2. The complexity, the amount of effort that we are going to put for solving a linear regression based model it is simple. When it comes to multiple linear regression, the efforts that we are going to put for cleaning the data, for understanding the data, and for doing all these steps, it is going to be a time consuming process and it is much complicated than linear regression. When it comes to use cases, if I am trying to predict a salary of a person just based on years of experience, just with one column, then it is called as linear regression. If I am trying to predict the salary of a person based on their experience, education, skills, and location, then it is called as multiple linear regression. So this is the example that I mentioned here. Now let's go through these steps that I'm going to follow for multiple linear regression so quick, because we have already seen this for linear regression. Most of the things are going to be common. So it is like again seeing the overview, or it's like a more like a revision. So the first step is data collection. For this particular project, if I am going to predict the house price of the house, then I need 4 different columns, right? I need to ensure if all the 4 columns are there. Area of the house, bedrooms, location of the house age, if everything is there or not. That is what I need to check, and I need to collect the data. If something is missing, then what I need to do? I need to call back the client, or I need to consult them through my mail, and I need to get the data. So I can work with that project and achieve my goal of the project. The second step is data pre-processing. Since by day 1 of this course, AI course, I am telling you guys that 70% of data scientists will be spending their time, or AI engineers will be spending their time in cleaning the data. So here is that step. What they'll do, they will be handling missing values. They will be encoding categorical variables. So when it comes to encoding, I mean, if I have 4 different categories, that will be converted into 0, 1, 2 and 3. So my machine can understand numbers clearly than categorical values. So that is called as encoding. The third step is feature scaling, understanding and keeping the important features. So based on my requirement, if I could change the values or something, that comes under feature scaling. The fourth step is removing duplicate records. If I see a particular column or a particular row is being repeated once again, that is called as duplicates. So removing that or handling that is called as duplicates. Handling duplicates or removing duplicates. And finally, detecting outliers. So in such scenario, if I see a particular value is deviated from the some value, then it is called as detecting outlier and removing the outlier. This step is much important to make sure that model learns from high quality and structured data. The third step is EDA, exploratory data analysis. If my goal is to understand the data, that is called as exploratory data analysis. What I'll be doing then? In this step of understanding the data, what I'll be doing here? I'll be creating so many charts. I'll be creating so many graphs. So if my exact data is converted into a picture, I can understand what is happening inside. That process will happen here. The fourth step is feature selection. If I have a goal of predicting a particular column, I might have 30 to 50 columns. I might even have 1000 columns. So in this step, I need to keep the important features or important columns that is useful for predicting the target column. That is something we will be doing here. If with the existing columns, if I could create new columns for making my model more efficient, that is what I'm going to do in this step of feature selection. The next step is train, test and split. Here the process of splitting my data into 80% training data set and 20% testing data set will happen, or I could convert my data into 70% training data set and 30% testing data set. So this process ensures that I am training my model and I am testing my model with the same data set. If I am giving similar data sets or something, my model is performing well or not. So for making sure, I need to divide my exact data set into 2 different parts, training and testing data set. Next part is training my model. Now I have decided this is the model that I'm going to use. This is my algorithm for this particular data set. So after deciding it, I'll be building the model, right? After building the model, I need to give the model. I mean, give the data to my model for training it. After giving it, it will be working on it and it will try to understand the data. So on the next step of training, I'll give my testing data set. So after giving my testing data set, I'll make sure if my model is performing well on my testing data set too. So in the same data set, I'll be giving 70% for training and 30% for testing, or 80% for training and 20% for testing to ensure the accuracy of my model. So in this model evaluation, we do have some evaluation metrics that we'll be using for evaluating my model. So to check the accuracy of my performance of the model. So in this particular step, we'll be having I mean, in this multiple linear regression model, we'll be having all these 5 metrics to evaluate my model. The first metric is R square value, adjusted R square, mean absolute error, mean squared error, root mean squared error. So in coding session, when it comes to hands-on coding session, we'll be clearly seeing what these values are and how it contributes towards the performance of the model. And finally, model interpretation. This is the important step. So in this step, look into this line. How much the dependent variable or the target variable changes when a feature increases by unit. So if a particular column's value is getting changed, how it is affecting my target variable. That is what we are going to clearly understand. So for doing that, what I'll be doing is, I'll be keeping every other values as same as it is. But I'll be changing a value for a particular column. And then I'll see in my target variable what is getting changed. That is what I'll be analyzing in this step. So that is why this step is very important in business and real world decision making. So after doing all the process, I'll be doing this to ensure that my model has the potential to handle new data that is coming from the environment. So in this video, we clearly saw what multiple linear regression is. Difference between linear and multiple linear regression, and also the complete workflow for building a multiple linear regression model. So in upcoming sessions, we are going to see about real world applications of multiple linear regression. And in another session, followed by that, we'll be seeing hands-on coding about multiple linear regression. This session is very much important. So the next upcoming sessions are very, very important. So don't miss any sessions. Make sure you hit the subscribe button so you'll not be missing out any videos, and also always turn on the notification. Always give priority to something that is going to help you in your growth. So bye for now. We'll meet you in next amazing video. If you have any doubts, without hesitation, drop them in comments. Bye.